Hi, so I have now Lego blocks. So I'm very excited about this. And I'm going to do some more fractions given that I have some new toys to play with. But I want you to think about this question. So first, I want you to think about the relationship between a half, a quarter, and 1/6, and represent these three fractions either using a number line or an area model or anything you like. And now after that, so it is a half, a quarter, and 1/6. Okay, so that's one combination. And after that part is done, and then if after you represented these three fractions, I want you to think about how the relationship between among these three fractions, how does that relate or connect to a relationship among 1/4, a half, and 1/3? Okay, I'm going to repeat it again. So first part is that I want you to represent and to think about a relationship of these three fractions. The first one is a half, second one is a quarter, and the last one is 1/6. I want you to represent these three. And after that is done, I want you to think about how the relationship among these three fractions, how does that relate to a relationship between 1/2, a half, and 1/3. So the second combination, second fractions, so 1/4, a half, and 1/3. Is there a relationship? Is there a connection? I want to think on that. But I won't answer that question because I want you to try on your own. However, right now I'm going to use these different Lego blocks and do some practice. So I will create a different sized hole, and the task is you will create as many fractions as you can make from that one hole. Okay, I will give you two examples so you could take a look. Okay. Okay, so what if we have, let's see, what if this is our hole? If this is a whole, how many different fractions can you make? I will give you just a few examples just to get you started. So for example, that right, I have one, I can fit 1, 2, 3, 4 equal parts. So this could be my 1/4. At the same time, I think I could do something different. What if I had something like this? What kind of fraction would that be? Well, if I had the same, I can fit this Lego piece 1, 2, 3, 4 times. So this also is a 1/4. And what else can I do? What if I had a piece like that? I have 1, 2, 3, 4, 5, 6, 7, 8. So this would fit 8 times. So this is my 1/8, right? So what if I had something like, let's see, this piece? So now I can't quite fit it in. So what am I going to do? So I'm going to actually, count how many dots I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 dots. And how many dots do I have here? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 and 16, I have 32. So this piece, I have 12 out of 32. Can I simplify that? Yes, I think I can divide both the numerator and denominator by 2. So that would give me 6, and 6 over 16. I can still divide this by 2. So that would give me 3 and 8. So that means I could have divided both the numerator and denominator by 4. But here you are. This is 3/8. Okay, what about this? If I have this one little piece right over there, what would that be? Well, I know that now that I have 32 little dots and I have only one dot right over here. So this is going to be my, I'm having issues. This is going to be 1/32nd? 32nd? Second? Yeah, 30, yeah, second. 1/32nd. Okay, and what else can I do? What haven't I done? So what about something like this? What would that be? Well, I have 3 dots, and I know that in total I have 32. So right over there, can I divide that by 3? No, I can't. So this is 3/32. And what else can I do? What haven't I done? So what if I had 3 of these ones? But I have 3 of these ones. Would that be the same as this one? So maybe not that. So something a little different. Okay, so what if I had 4 of these? I'm running out of space. I'm gonna just push it over right over there. What if I had 4 of these, not 3, 4 of these? Well, 1 and 2, right? So if I had 2 equal pieces, then I can put this twice. So that means this must be my half. Yeah? And what else is there? What about this one? I have these little one, this little one, and I can put this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I can put this 16 times. So this is going to be my 1/16, right? And what else is there? What haven't I done? What about these? What if I had is it visible? Yes. What if I had something like this? This little piece right over there. What if I had something like that? And adding a bit more. What if I had something like this? What would that be? What would that be? This one. What would this be? Well, I have one hole, right? And if I'm only looking at this green piece, this is a half of this one. So I can actually go over one hole and say 1 hole and a half, right? So this would be my 1 and a half. I can also represent this as 3/2 as well. So this is one of the ways that you can play around with Lego pieces. This is a really good practice. And now I want you to pause and think about this. And if I gave you a different half, what would it be? So what if I said, now I am going to decide this is my half. Would the half of this piece and half of this piece, whoa, you can't see. So if I said this is my new hole, and I want you to think about, okay, half of my original piece, original hole, was this much. But now if I said this is 1 hole, all of these fractions would be completely different. So I want you to think about this question. When you are comparing fractions, if you wanted to compare fractions, what do you have to have? What is the condition in which you can compare fractions? I'm going to ask again. So if you wanted to compare fractions, what is the condition that you have to have in order for you to compare fractions? And I want you to think about this of the a quarter, we have 3/8 and we have 1/8 and all these things. And I want you to think about what do you have to have in order for you to compare different fractions. And I will give you a different whole and then we're going to go over it and I want you to think about it. Okay? So that's done. So now this time I'm going to say this is my whole. This is my whole. Okay. This is my whole. What would that be? Well, I have 8 dots. I have 1 dot. So this must be my 1/8, right? And what if I had that? This I can fit 2 equal parts. If I had 2 of those, so this must be my half, right? What if I had something like this? I have 3 dots. Whoops. I have 3 dots and I have 1, 2, 3, 4, 5, 6, 7, 8. So this is my 3/8. And what else can I do? What if I had something like this? What would that be? Maybe I would do it like this. So what is that? Well, I can do my regular way. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 dots and my original whole, it has 1, 2, 3, 4, 5, 6, 7, 8 dots. So I have 12 dots out of 8 in order to make a whole. So I can once again simplify this by dividing by 4. So with this one, I have 1 whole and a half. And if you see it, if I put it right over here, you can see that if I put these two together, I will get 1 and a half. So you can see that this is my 1 and a half or 3 halves. So that's one of the ways. And what else can I do? I can, for example, what about this one? Yep, I can fit 2 equal parts if I had 2 of those. So this is also my half. And what if I had that? If I had that, well, now I have 1, 2. I have now 2 wholes. Right? I have 2 wholes right over there. And with 2 wholes, you can always write it as this way as well. Okay, what else can we do? Let me see. What if I had that? So it's not quite a whole. I have 6 dots out of 8. So this one is, and I can simplify 6 over 8, 6/8, and I can simplify this by dividing both the numerator and denominator by 2. This is my 3/4. Well, if this is 3/4, can I create a 1/4 using something? And let's see. If I had something like this, or because I have 1, 2, 3, 4, 4 equal, 4 of these would fit. So this is my 1/4. But I could also have represented that with, if I had 2 of these, I could have used both of these as well. But what about this one then? I could put that, and this is 1 dot out of A, so it is my 1/8. So that's, you could keep on going and going and going, and you can make as many fractions as possible. If you want to do something a little bit more complicated, you could use some different sized ones and then put it all together and try to figure out fractions. So Lego pieces are awesome, brilliant tools for anyone to explore fractions, and I love it. And so now I want you to quickly look at all of these. So, and think about, well, if the whole is, well, who decided what is going to be my whole? Well, I did. I decided this is going to be my whole. So, in a way, I kind of don't want to give out the answers, but there is a hint right there. Think about who decided what is going to be my whole. And deciding on what the whole is, that would determine what your fractions would look like. So on that note, I will sign off and I'll be back. Thank you. So fractions and I have a very turbulent relationship with history, shall I say. And the reason is, when I was in elementary school, so this was what my elementary school teacher said. So the teacher showed me an apple, and I said, and she said, well, I have 1 apple. If I cut an apple in half, I have 2 1/2, right? 2 1/2s. And when she cuts an apple in 4 equal parts, then she said I have 4 quarter pieces, right? Because you have 1/4 piece, 1/4 piece, 1/4 piece, 1/4 piece, and altogether you have an apple. And I really didn't buy into that, because to me, well, initially you had 1 apple, but then at the end, I didn't see 1/4, I saw 4 pieces, and I didn't quite understand what was this 1/4 was. I really didn't understand it, because, well, you had 1 apple, and if you change the unit of measurement, instead of having 1 piece of apple, you have 4 sliced apple, like 4 sliced apple pieces, and that was that. You didn't have to use this 1/4 business. You could just say 1 apple to 4 slices, and I didn't see any need to move from whole number to this fraction business. I didn't understand it. But in a way, what my teacher should have said was that when we are thinking about math, you are in charge of changing numbers and manipulating and controlling numbers. That means you can decide what it is, what your whole is going to be, right? So if I am looking at, so just think of it this way. If you decide 1 apple is my whole, then if I cut an apple into 4 equal parts, then 1 little sliced piece is going to be 1/4 of an apple, because 1 apple is your 1 whole. But if you decide, you know what, this my 1/4 piece, this little slice is my whole, then you can say you have 4 wholes. That is you deciding it. And that is a really, really important point, because when you are thinking of fractions, for example, when do you use fractions? Maybe you're cutting, maybe you are dividing something, or maybe you are thinking of percentage or something like that. And someone is deciding what the whole is. That's 100%, that's 1/1. That's your 1 whole. So know that whenever you are dealing with fractions, you have to know what the whole is and who's deciding it. And sometimes you could be the one who's deciding it. So that's a very, very important point. And without knowing that, I was really confused when I was in elementary school. So this is my sort of a tidbit that I wanted to share, and I hope you enjoyed the Lego fractions. If you have any questions, please leave a comment, and I look forward to it. And thank you very much for watching. Bye bye.